Welcome everybody. My name is Rob Schultz. I teach AP Computer Science A at Bellbrook High School in Bellbrook, Ohio. This is topic 1.3, expressions and assignment statements, video number 2. Okay, so in this video, we're going to build on what we did in video 1. In video 1, we learned about the 5 basic assignment operators. We're going to build on that now, and we're going to look at how we actually evaluate compound expressions. So we're going to take those 5 operators and put them together to create bigger more complex arithmetic operations. So our learning objective is still to evaluate arithmetic expressions in program code, but now we're going to look specifically at how we construct compound expressions. We're going to talk about order of operations a little bit. Java is just like algebra. We use algebra when we do our calculations. All of those same rules apply. And we're going to throw in one extra little piece at the bottom to show what happens when we do something like trying to divide specifically by 0. That throws an exception. And if you think back to topic 1.1, we did in, I believe it was video 3, we looked at error types, syntax errors and logic errors. Well, this is going to be our first exposure maybe to what an exception is and what happens when we throw an exception. Okay, so just a little bit of quick review. In video 1, we looked at the 5 basic arithmetic operators: addition, subtraction, multiplication, division, and modulus. And we looked specifically at what modulus did. So if you're still not comfortable with modulus, you might want to back up and watch video 1 before we go on. Okay. Now we're going to look at what's called a compound expression. This is where we take those operators and we build more complex arithmetic expressions. And to evaluate this, like I said, the rules are exactly the same. Algebra doesn't change outside of your algebra class. We're applying algebra to solve this, which means we have to follow the same rules of orders of operations, okay, which if you think about, what you learned in your math classes, PEMDAS, please excuse my dear Aunt Sally, purple eggplants make delicious afternoon snacks. I mean, whatever method you use to remember that, the same rules apply in Java, but we build on it a little bit. Okay, so we're going to focus specifically on the multiplication, division, addition, subtraction part of all that. We also have modulus that's now thrown in. Okay, so multiplication, division, and modulus all have the same precedence, and we work from left to right. And after we've evaluated multiplication, division, and modulus, then we look at addition and subtraction. So looking at our complex compound expression that we have on the left, we're going to start on the left-hand side, and we're going to scan our way from left to right looking for any occurrence of multiplication, division, or modulus. Now, the first thing we find is 8 times 6. Okay, so we have to evaluate that before we can move on. 8 times 6 becomes 48. So as we continue to move across, we find 14 modulus 3. Now, notice that it doesn't do them in a specific order. We're not going to look for multiplication and then go back and look for division and then go back and look for modulus. They all carry the same precedence, so it's whatever order I find them as I move left to right. If you think back to what we did in video 1 for topic 1.3, modulus gives us the remainder. So 14 modulus 3 is going to give us a result of 2. As we continue to work our way across, the next one we find is division, so 8 divided by 2, which is going to give us a result of 4. So after I've gone from left to right through this entire line, we end up kind of simplifying it down, doing all of the multiplication, division, and modulus to 48 minus 2 plus 4. And now we go back again all the way to the far left-hand side, and we start looking for addition and subtraction. So the first thing we find is 48 minus 2, which is going to give us a result of 46. 46 plus 4 gives us a result of 50. So 50 is the final result for this, following order of operations. Okay, now like I said, our order of operations is the same as when we're in our math class, and we also have to kind of take into account we've got parentheses thrown in there. So parentheses still comes first if I'm doing an arithmetic operation. So if I put my 3 plus 8, if I go back and take that same compound expression and I put the 3 plus 8 in parentheses, let's look at what changes, okay? First thing we have to do is we have to deal with the parentheses, and our only occurrences of parentheses is 3 plus 8, which is going to give us a result of 11. So once I've taken care of parentheses, now we go all the way to the left and we focus on multiplication, division, and modulus again. Well, just like last time, we start with 8 times 6, which is going to give us 48. We now have 14 modulus 11, which again, if I take 14 divided by 11 and look for the remainder is going to be 3. So now this becomes 3 divided by 2, and remember back in video 1, we talked about the fact that if I've got an integer divided by an integer, I'm going to get an integer answer. So even though in our math class, right, if I were in taking my Algebra 1 class or Algebra 2 class, 3 divided by 2 is going to be 1.5. In Java, 3 divided by 2, integer divided by integer, is just 1. So we have to be careful and remember that, okay? After we've gone all the way left to right and we've taken care of all of the multiplication, division, and modulus, then we go back to the left again and we look for addition or subtraction. And in this case, we only have one occurrence. That's 48 minus 1, which is going to give us a result of 47, okay? When I plug these into a little program, all of that evaluation is going to take place kind of in the background, and I'm still going to end up displaying 50 and 47 as my output. The one thing I wanted to point out was in topic 1.2, I had to think about it for a second. In topic 1.2, you talked about variables. You learned about variables. We can also declare these values, and we can do arithmetic operations using variables. So for example, I can say int x equals 3, int y equals 2, and then I can plug those variables in. Everything still works out the same. My x has a value of 3, my y has a value of 2, so we're using the value that is stored in those variables to do our operations as opposed to literal values themselves. The one thing that I wanted to point out, and the reason I bring the variables into this, is because if you think back to topic 1.1, video 3, we looked at different error types, and we looked specifically at syntax and logic errors. Well, there's also this error that's an exception, and an exception occurs when the program is running and something abnormal happens, something that the compiler can't handle that it comes across after the program starts running. This is referred to as throwing an exception. And an example would be if the program attempts to divide by the number 0. We can't do that, okay? So if I look at this little example I did where I included variables, everything that's in here is syntactically correct. The compiler is not going to notice that there's any kind of a syntax error in here. But because y equals 0, and then later in the program I try and divide by y, what I'm essentially doing is I'm trying to divide 8 by 0. And that's an undefined result. We can't do that, which means that we're going to get this error that pops up on the screen and brings everything to a halt that says there's an exception in thread main. It's going to give us a specific line number. It's going to point out the line number of where the error is. And if you count, you'll see that this is actually line number 11. So it's telling us that we've got an exception in line 11. We're trying to divide by 0, and we can't do that. So it makes it a little easier for us to go back and find that error. Okay. So that's our video for today. We have looked at compound expressions. We can use operators to construct compound expressions. During evaluation, operands are associated with the operators according to precedence. In other words, we follow our same order of operations. And if by some chance we attempt to divide by 0, if we divide an integer by 0, the result is going to be we're going to throw an arithmetic exception that's going to crash our program and basically bring everything to a halt. Okay, thank you for watching. Please continue to watch all of the videos that follow. I hope everybody has a great day, and I'll see you the next time.